Math with Oscar class. That's my dad.
All right. Our first example is to find the area of a regular square pyramid with an edge of 5 and a slant height of 9. Now that's an important distinction we got to talk about. Slant height versus altitude. Now, here I've got a pyramid. I'll put 5 along each of its base edges. Then I'm going to write the slant height is that right there. Now notice it comes from the apex, the vertex, the top of my pyramid, comes down along the edge of the pyramid. We use a cursive L to represent that. So that gives me a slant of 9. Now that's different than the altitude. The altitude is that distance in there, the distance from the peak of the pyramid straight down to the base, hitting at a right angle. If I were to look at this pyramid dead on from the side, not in 3 dimensions, but a flat side image of it, here's what I might see. So there's my sideways view of it. It's 5 units along that base there. It's 9 units along that side. So if I were to slide down the side of the pyramid, that would be 9 units long, in this case 9 inches. And then that would represent the actual height or the altitude of the pyramid. Now our book does a pretty good job of differentiating between the two. You'll see the term altitude versus slant. Slant refers to that side, the leaning part, the slanted part, whereas the altitude is the distance from the peak straight down. Now, the good news is our formulas tend to be pretty easy to use if we're talking about the slant. So, the lateral, well, let's say not even worry about using the formula. I'll leave it to the book to explain the formula. Let's take this figure and break it down. I'm going to open up this pyramid. Now, we've worked with nets, and you've seen that a pyramid is made up of a square with several triangles leaning in on it. And we can calculate the area of each of those pieces. And that's what we're going to do here. I've got my base piece. That's 5 units on the side. And then I've got these triangles going around it. Now those triangles are going to fold up into this figure. That'll give me the original. Now the good news is this is the slant height. So that's factored into my equation. I can then find the area of each of those 5. If you're following the textbook, it talks about the lateral area. That is the sum of those 4 triangles. It's a viable strategy if you like your formulas. Me, I like to break it down into parts and work from there. So, I've got 4 triangles. So that's 4 triangles, each being 1/2 base, 5, times height, 9. So half base times height, plus my bottom base, which is 5 by 5. So now what I can do is go through and calculate that. This is going to work out here. Let's see, that's 45. Half times 4 gives me 2. Whole thing works out to be 90. Then I can look at the base. That's going to be 5 by 5, or 25 square inches, giving me a final answer of 115 square inches of surface area for the entire pyramid. The lateral is just this piece right here. The total surface area is that piece down there. Now where we're going to be practicing this, our main goal, our main objective, is to actually provide just the lateral area. Or sorry, just the surface area. We're not generally going to ask for lateral. Lateral is a good step towards surface area, but you don't need it by itself. You only need to come up with your final answer of 115 square inches. While the textbook worksheets like to ask you to calculate both, I'm mostly interested in this final answer of surface area. Lateral area here would be 90, total surface area is 115. Stick around for another minute, and what I'll do is I'll use the actual formula the book provides to also get this exact same answer if you're a formula junkie. So now let's take a quick look at how the book handles this just using the formula for those that prefer formulas straight up. The book formula is the surface area is equal to the lateral plus 1 base. Now think about prisms. Prisms, we said it was going to be lateral plus 2 bases because there was a top and a bottom. Here I only have the one bottom, the one base down at the bottom there. So in this case, my lateral area is taking into account the fact that we're going to go all the way around the figure. We're going to use the slant height as opposed to the altitude. And we're going to deal with the fact that it's only 1/2 when we break it down, because all of these are triangles, and the default formula for triangle is half base height. And again, unless you're really good at memorizing formulas, I really recommend you think of this as 4 triangles and a square, rather than trying to memorize all of the individual formulas themselves. But if you like your formula, let's go ahead and take it out for a spin. The lateral is 1/2 perimeter times the slant plus the base. Now the good news is we're going to need that formula for dealing with cones, because cones we can't break into polygons. This guy's not a cone, don't need to worry about that. So now I can go ahead and plug in my formula. 1/2. The perimeter is going to be 5 plus 5 plus 5, 4 times, for a total of 20, times a slant of 9, plus the area of that base. And that's a square, so it's 5 by 5. So now I've got that area. When I calculate this out, this, the lateral area, capital L, again works out to be 90. My base works out to be 25, and I'm left with an answer of 115 square inches. And that 115 represents, again, my total surface area. Formula works just as well as breaking into parts.